So, what is a bridge? A bridge is a structure designed and built of span a physical obstacle, such as body of water, valley, or road. Bridges can be made from a variety of materials, including wood, stone, concrete, and steel. Engineers design bridge to withstand load and forces such as wave, wind, and earthquakes. Engineer must fully comprehend the bridge issue and goal in order for the design to be appropriate, effective, and economical. Engineers could design a bridge for a train. If they were just told it must cross a body of water, the bridge would be overbuilt and overly costly. If it were genuinely intended for pedestrians and cycling, there were some factors to be considered when building a bridge, such as survey, geotechnical, engineering, and right of way.
Hi, Assalamualaikum. My name is Muhammad Khairil Anwar bin Yaakob. Next, I would like to talking about type of bridge. Bridge and viaduct serve the same purpose and there are many different perspectives on their similarities and differences. According to the Kaushik 2011, not all bridge are viaducts and not all viaduct are bridge. The contrast is due to the primary use, position and construction. A viaduct is a long bridge or combination of bridge linked together by arch bridge that carry a road or railway across a valley or gorge. More than that, there are four main types of bridge. First, beam bridge. The beam bridge is very simple and are the most common type bridge that usually cover for short distance. For the second bridge is arch bridge. The arch bridge is one of the best shape used in bridge design with the curved structure. It is impossible to collapse or break, which provides a high resistance to bending force. Next, cable stayed bridge. A typical cable stayed bridge is continuous girder with one or two towers erect above piers in the middle of the span. Lastly, the suspension bridge. The suspension bridge allow for the span with length 70 meter to more than 1100 meter. Next, for the component of bridge, they are divided to three types of major components, which superstructure, substructure, and foundation. There are three components of foundation which are piles, caps, and bands. Substructure is the component of bridge that support the superstructures and transfer the load to the foundation and footing is called the substructure. They are made up of piers, abutment, and wing walls, all of which help to transmit the load weight to the earth. Lastly, a bridge superstructure is its primary component. The load is supported by the superstructure as it crosses the bridge. It consists of the slab of the deck, bearings, ginders, parapet walls, tower, cable, anchor, and hanger.
Design consideration. There are some design considerations that need to consider before building a bridge. The first one is location. The team should survey the area to figure out optimal bridge location, and the site must be perfect location in the area for a bridge. The second one is construction timeline. The design must be perfect during pre-construction because any minor mistake or miscalculation could cause in bridge collapsing. The third one is live and dead load. Values for these loads depend on the bridge use and location. Then, fourth consideration is tension and compression. According to Digital School Technical Design College 2023, the bridge will be affected by compressional stress, which works in opposition to tensional stress. Lastly, superstructure and substructure. Even both had opposite objective, the superstructure and the substructure are worked together. For example, choosing the bridge structure shape will have an impact on the bridge. A bridge can have an architecture shape, be suspended by cables, be constructed mostly of strong beam, and more.
Let's move to the method of construction. Hi, my name is Nur Alia Akila. A variety of bridge construction method must be used depending on the location and type of bridge. Now, I will explain each of the several bridge construction methods. The first one is precast bridge construction method. Precast construction refers to the process of prefabricating bridge members or segments off-site, transporting them there and installing them. When compared to cast-in-place segmental bridges, construction with precast segments has a number of benefits. The second one is precast in situ bridge construction method. This approach offers a number of benefits including lowering direct expenses, lowering material, labor, rebar and shipping costs, and it quickening formwork. The third one is balanced cantilever bridge construction method. It is one of the most often utilized method for building bridges. It is referred to as a balanced cantilever when two opposing free cantilever structures are joined together as a single structure and built in one stage. The fourth one is span-by-span casting bridge construction method. The most typical, easiest and frequently most economical construction method for precast segmental bridges is erection span-by-span. It is usually aimed for long bridges with a lot of 25 to 45 meter spans and a big plan radius, and it is suitable with continuous and simply supported spans. The fifth one is incremental launching bridge construction method. In civil engineering, incremental launch is a technique for erecting a full bridge deck from just one bridge abutment while building the superstructure of the bridge in parts to the opposite side. Pre-stressed concrete is used in the method's modern application, which are highly mechanized. And the last one is advanced shoring bridge construction method. The movable scaffold system (MSS), an innovative shoring technique, was created for multi-span bridges over challenging terrain or water, where scaffolding would be prohibitively expensive or just not possible. The technique, whether used underslung or overhead, is very flexible to a variety of spans and superstructure types.
Next, I will present the construction process. At the earliest stage of bridge construction, mainly will apply typical construction process for all types of bridge, and in this section, I will explain the balanced cantilever and also incremental launching bridge. For balanced cantilever, the first step is to relocate the existing services. The contractor will install roadway barrier as preventive measure to ensure that the public safety along the construction of bridge, and then will proceed to the relocation of the existing services. It then will widen the construction area and roadway passage to reduce the construction disruption, in which the road will be diverted to the other location to separate the public users away from the construction area. Next is excavation works and substructure formation. The construction will begin by excavating the earth structure to receive the platform level. Pilings will be driven at the piling points by using driving equipment. After that, the pile cap can be formed with in situ method. The construction of bridge will conduct by using an advanced form system to accelerate the formation of bridge piers, which are then to be used as the working platform for the carriage piers to form the travelers. And the last step is the segmental girder construction. When the construction of piers is completed, the scaffolding will be installed around the pier as support for upper structure. Each part of the formwork, such as sides, edges, and soffit of formwork, will be assembled together as the traveller mode and ready to be filled with concrete and fabric reinforcement. It usually takes a week of production period for each segment to be ready. The balanced cantilever will move simultaneously on both sides of bridge, which will constantly continue until the traveller meets the midpoint of the bridge. Next is the incremental launching method. It requires to use the launching system, and at the side, the prefabricated slide at the permanent pier will be installed. The bridge pier will be constructed either in situ or prefabricated depending on the construction. The prefabricated launching will be equipped with base plate called MGE plates lying off at the bottom of the platform, and it then will install the launching girder guide. Special formwork will be placed to form the in situ segmented girder, including placing the fabric reinforcement and concreting works. Each part of the segment girder requires at least 5 to 7 days for the structure to be ready. Hydraulic jacking will be placed at the bottom of the launching platform to move forward the girder to the next pier. And lastly, the dismantle works as well as abutment of the bridge will be done.
Material used. There are a few of the material used in bridge construction. The first one is concrete. Concrete also is the best building material for every bridge project, regardless of size, form or intended purpose. The second one is pre-stressing concrete. Pre-stressed concrete result in lighter design that are frequently less expensive than design using reinforced concrete since it reduces the amount of steel and concrete required in a structure. The third one is steel. It is a strong and adaptable material that offers practical and sustainable solution. Then the next material is cast iron. Component is compressed during construction and it has a very strong resistance to compression. Then it is timber material. The increased focus on sustainability and environmental issues has undoubtedly led to a rise in the use of structural timber, but other creative uses of the material such as stress-laminated deck and stronger connection are also important. Next is stone. Stone can resist some force in shear and compression. Lastly, advanced composite material. As more people become aware of the benefits of composite, many fabricators and suppliers say that conversation with civil engineers are shifting away from resistance to change and doubt about the material capabilities and towards other issues like cost and the material's capabilities.
Now I will explain the brief of project for our case study. The case study chosen for our report is Second Penang Bridge. When finished in November 2013, the Second Penang Bridge, which spans 16.9 kilometers of water to connect Batu Kawan on the mainland with Batu Mau on the island, will be the longest in Southeast Asia. The estimated total cost of construction is 4.5 billion ringgit Malaysia. As we can see in the table, the length of bridge is 16.4 kilometers and the length of expressway is 7.1 kilometers. The lane configuration is 2 traffic lanes in each direction, each with 1 motorcycle lanes. And for the method of construction, it uses approach spans and main spans. For approach span, it uses precast pre-stressed segmental box girder. Meanwhile, for main spans is cast in situ cable stayed bridge. The parties involved in this case study is as shown in the table. There are 9 contractors involved to make this project a success. The contractors involved include CHEC Construction M. Sendirian Berhad, UAM Builders Berhad, Cergas Murni Sendirian Berhad, IJM Construction Sendirian Berhad, HRA Teguh Sendirian Berhad, SU Citra Bina Sendirian Berhad, Trust Technology Sendirian Berhad, Itramas Technology Sendirian Berhad, and lastly TN Synergy Sendirian Berhad.
Major components. There are the major components of Penang Second Bridge. The first component is precast pre-stressed segmental box girder. The continuous signal twin box of the precast segmental box girder is 4.08 meters in width, 4.0 meters in length, and 3.20 meters in depth. There are 8,092 nodes of precast pre-stressed segmental box girder used at the superstructure of Second Penang Bridge. Second major components are piles. The case study of Second Penang Bridge used 3 types of pile, which is 2.0 meter diameter board pile for cable stay bridge, 1.5 meter diameter steel pile for approach bridge, and 1 meter spine pile for low level bridge. Next, pile caps. Precast concrete shells are permanently incorporated into the pile cap and used as a formwork for the casting of the second layer. The Second Penang Bridge consists of 3,468 precast concrete shells in total. After that, height damping rubber bearing, which is HTRP. The bearing was made to adhere to 2 different set of action standards, namely SLS non-seismic action conformance with BS 5400 and SLS non-seismic action simultaneous with a 2,500 years return period, seismic event conformance with EN 15129. Lastly, stay cable. The stay cables are made up of the parallel strand system, PSS.
Next, for the type of construction used. According to the ARUP 2015, The main span of the second Penang Bridge is 240-meter long cable-stayed construction with concrete edge, girders and a deck slab. At the towers, the first segment and pairs of stay cables were cast in place on falsework. Beginning with the second segment and stay cable, the edge girders and deck slabs were cast utilizing a travelling formwork system using balanced cantilever construction. A 16-kilometer long marine viaduct with 55-meter span precast concrete segmental box girders was built in shallow water. They built bridge by span by launching girders.
In the case study, the second Penang Bridge implement two types of construction method. The first phase of construction of bridge, they use span by span method to construct the approach span from P0 to P24 and P27 to P292. The approach span use precast prestressed segmental box girder. Next, it will proceed with constructing the substructure work such as piling, pile caps and also piers. The process of making the substructure requires no cofferdam at all. Then, the rubber bearing is being placed beneath each of the segments to adjust the seismic frequencies. When all the piers is ready, plant and equipment such as launching gantry, strand jack is installed. The segmental box girder are made fabricated at the factory nearby the construction site. It is made and designed specifically to be waterproof as the superstructure is constructed above the sea level and is sensitive to the marine environment. The formation of segmental box girder is erected by using span by span method with the utilization of launching gantry and assembled with expertise guidance. And lastly, the epoxy sealant is used to seal the joints of the concrete girders. For the main span, they implement balanced cantilever method to construct the cast in situ cable stayed bridge at P24 to P27. First is construction of substructure works at the center of Penang Bridge. They use board pile foundation as their main substructure works and driven up to 130 meters below the seabed. Moving on to the pile cap formation, there are two different sizes of pile cap is used, but both still made up from special formwork called permanent steel fender system. The process is followed by lean and concrete pile cap formation. The pylon structure is constructed to support the cable stayed and made in reinforced concrete by using hydraulic self-climbing formwork to form the lower and upper section of pylons. Next is the erection of main span deck is between P24 to P27. The process is carried out alternately and repeats the same process until both beam meets the middle of the bridge. The steel cables are strung and stressed individually to maximum strength anchored to the side of the deck through the holes opening. The finishing process of road formation is by doing road marking and other remaining works.
Moving on to the problem occurred during construction and steps taken to solve it. The longest bridge in Malaysia is the second Penang Bridge. The company in charge of the bridge desired a structural health monitoring system for protection of such an investment and for the safety of bridge users. The solution for this problem is the firm appointed a company partner in South Korea company to implementing solutions. Next, it was discovered that one of the issues affecting the second Penang Bridge project's timeline was a need for more supplies, equipment and tools. However, the client's representative noted that the issue of land acquisition from the landowners had arisen as a result of the consenua shifting because there needed to be an authority in charge to address the land acquisition issue. There may be times when using an elevator is a much safer option for avoiding harm to large objects when steps must be navigated. If your employees are adequately trained, you shouldn't have to deal with too much material loss due to improper handling. Lastly, to investigate, the Department of Occupational Safety and Health, or DOSH, issued a stop work order. Structures should be inspected by safety and oversight experts during audits, and miners should get training to identify and report potential structural issues. A structural engineer should formally evaluate the structural integrity regularly. While conducting inspections, exercise all necessary personal safety precautions such as wearing fall protection when working at heights and adhering to safe confined space entry protocols. As a conclusion, bridges are an essential part of modern infrastructure and have played a crucial role in connecting communities. They come in many different forms, from simple beam bridges to complex suspension bridges, and are designed to suit a wide range of environments and uses. A comprehensive procedures that cover structure, planning, design, building, and maintenance must be devised. A comprehensive plan should be considered during the entire design process for a successful bridge development. Any structure will have a long useful life when all the factors are considered. Using durable materials such as steel and concrete and implementing the latest technologies can also improve the longevity and safety of the bridge. That's all from us. Thank you very much.